So till now we have completed the first, or you can say 50% of the second module, and now we have to start the last part of the second module, that is the trust. So let me share the screen. The screen is visible now.
Yes, sir, it is visible.
So this is the last article of the second module. Trust. So trust is basically a assemblage of different members, different rods when we are connecting it to form a network of triangles. Means if we go for a simplest truss, then we have a simplest triangular perfect truss, which is in this shape. Like you can see this, the shape will be like that. This is the simplest perfect truss. So you can see this. This is A, this is B, and this is C. So we have three members, A, B, B, C, and CA. They are the three members here. You can see three members, and similarly you can see we have the three joints, A, B, and C. So we have three joints also. Fine. So this is the simplest perfect truss, or you can say simplest triangular truss. So what is a truss? It is a truss is a assemblage of number of members when they are connected. So you can see this. This is the rod, one rod. This is second rod. This is third rod. So we can connect these rods with the help of welding. Welding you are doing in the EME lab, elements of mechanical engineering lab. Welding is a process in which two pieces or the two parts are joined together with the help of heat. So with the help of fusion, we can say, and we just heat them to their crystallization temperature, and then we allow them to cool. And after cooling, we get the final product. So this is here we have to how we have to uh, join these different members. So this is a perfect. This is an example of a perfect simplest truss. So what are the different applications of truss? You can see you have seen it in the railway platforms here. You have seen the roof of the railway platform that is also in the form of truss, and also you have seen the bridges. You can see the bridges. Bridges are also in the form of trusses. Different number of triangles are connected side by side. Similarly, transmission towers. So transmission towers are also the part where you can see the trusses. Fine. So these are the different types of trusses which we came into which we came into action, or you can say in the practical life example. So let me give you the brief of here. What is actually we have to study in this? What is basically the triangle or the stable part of the truss? So if we see here for the perfect truss, or you can say the truss. Truss is basically this is a table what I am writing here. This is here. This is perfect truss oblique rigid truss, and the second one is imperfect truss.
Sir, sorry for joining the class late. My internet was not working.
Okay, no problem.
Thank you, sir.
Imperfect, we have two types, deficient, and the second one is redundant truss. Okay, so this is the basically you can say how we can classify a truss into different types. If anybody asks you in the viva or in examination 1 or 2 marks theory, they will ask you what is truss and classify the truss. Then you have to make this chart. Truss is classified into two parts. One is perfect truss or the rigid truss, and second one is imperfect truss. And imperfect truss is further divided into two parts. That one is deficient truss, and the second one is redundant truss. So what we are going to study in this our discussion, we will be studying only for the perfect truss. Analysis of the perfect truss we are doing in our this syllabus, but we should also know what is an imperfect truss. Fine. So let me go to the one more part here. This is one equation, m is equal to 2j minus 3. This is one equation. If any perfect truss of or a trust, we are not saying any perfect. We are saying if any trust satisfies the above equation, you can say this equation m is equal to 2j minus 3. If any trust satisfies this equation, then you can say that the trust is perfect trust. Fine. And for a deficient trust, you can see this here m should be less than 2j minus 3, and here in this case condition will be m will be greater than 2j minus 3. So the other two conditions that you should know. Then you can tell that a given trust is perfect or imperfect. If it satisfies the equation m is equal to 2j minus 3, then it is a perfect trust, and if it is not satisfying the equation, then it is an imperfect trust. And further, imperfect trust is divided into two parts. One is deficient trust and other is redundant trust. So deficient in this case, you can say m is less than 2j minus 3, and in redundant you can see m is greater than 2j minus 3. So if I put this equation here, you can see which I have drawn here, the left hand side. You can see here, if I apply to this equation m is equal to 2j minus 3, so you can see how many members are there in this triangle trust? 3. AB, BC, fine. AB, BC, and C. We have the three members here, and here we have the joints A, B, and C. So joints are also called as nodes. So you can make a note of here. Joints are also called as node at some places. In some books, they can say that a node or joint, so both are same. So you can see m is equal to 2j minus 3. So if I put here m is 3, and what is j? J is the number of joints. How many joints are there? 3 minus 3. So how, what they will get? They will get LHS is equal to RHS. So we can directly say that trust is perfect trust. Why? It is satisfying this equation. Fine. So one condition is that it should satisfy the equation, and the second condition for a trust to be perfect is that it should not deform under the action of forces. Means, for example, if I say here, if this is the trust here, can you tell me the name of the trust? I am just drawing it here. This is how I have drawn it, A, B, and C. So let us say this distance is 5 meter and angles are equal. And let us say the load here is 15 kilonewton. So can anybody tell me which type of truss is this?
Perfect.
Perfect truss is fine, but
Perfect.
one more thing you can see. You can see the diagram and then you can say we have done everything in the beam also. Can you see? Can you
Please
recognize?
supported.
Simply supported.
Simply
Yes,
supported.
yes. Excellent, excellent. That means this truss is a simply supported perfect truss. Fine. Why it is simply supported? You can see at the point B and the point C, we have the two supports. At the point B, we have hinge support. At the point C, we have the roller support. So we can say that this is a simply, or you can say the name will be simply supported perfect truss. This is a simply supported perfect truss. Fine. Now, I was telling you the condition. One condition was, what is the first condition? M should be equal to 2j minus 3. This is the first condition for a trust to be perfect. And the second condition is, I am writing it here for you. On the application of load, trust should not deform. Okay, so this is the second condition. If two conditions are satisfied, then you can say the truss is perfect truss. Means you can see that at the point A, we have applied the load 15 kilonewton. So by the application of this force, if the direction of the, or you can say the members of the truss A, B, B, C, and CA, if they bend, okay, if the direction, or you can say the lengthwise, let me say that it get extended due to that, it might get extended due to that. Okay, so if the length of the AB, AC, or you can say the nature of forces which are acting in the different bar, or you can say rod or members of the truss does not changes, then we can say that this truss is a perfect truss. So we have the two conditions here. Number one is M should be equal to 2j minus 3, and number two, on the application of load, truss should not deform from its original shape. So this is the second condition for a truss to be perfect. Okay. So if anybody asks you what is the condition, then simply you have to say m is equal to 2j minus 3, and the second one is on the application of load, the truss should not deform from its original shape. So this is the very important condition you should know. So till now I have told you what is truss. I have explained you the assemblage of different forms of triangles, and then where it is used. It is used in bridges, it is used in transmission towers, it is used in railway platforms. The shed or the roof is in the shape of truss, and the simplest perfect truss is a triangular truss. And then I have discussed with you what are types of truss. Classification is perfect truss and imperfect truss. Perfect, m is equal to 2j minus c equation should be satisfied. Secondly, on the application of load, truss should not deform. And the next part is imperfect truss. In this, we have simply that m is equal to 2j minus 3 equation will not be satisfied in this. And secondly, on the application of load, truss may deform from its original shape. So this is the example. This is the imperfect truss, and we have two types: deficient truss and redundant truss. In case of deficient, m is less than 2j minus 3, and in redundant, m is greater than 2j minus 3. So till now, what we have discussed is clear to you.
Yes, sir.
Okay. Now I will tell you one important definition or one important difference that comes in examination. Difference between truss and frame. Truss oblique frame, or you can say difference between these two. What is the difference between these two? So I am making a diagram here so that it can be clear to you. This is one diagram. Okay, and you can see this is a load here. This is one diagram, and this is the second diagram. You know, trusses can be of number of triangles can be there in a truss. So I have just taken the simplest truss. So truss can be have this type of triangles. You can see this. This number of triangles can be there also in the truss, like that. This is also a truss. Okay, this, if I can make it like that, if I make it like that, so this is also a truss. This is also a form of truss. So truss have number of triangles, number of assemblage of triangles, and each triangle is made of different number of members. So ignore this part here, ignore it. I am talking right now for this part, this, and now see this. Let us figure it out ABC, and let us figure it as DEF. So can you see the difference between these two figures? What is the main difference between these two figures?
Point of application of force.
Yeah, you should not say force, you should say load. Okay, point load.
Okay, sir.
So see, this is truss and this is frame. So it is clear now. So I can explain you in words also. If anybody asks you, please tell us the difference between a frame, then you have to say that in case of truss, load is applied only at the joints. So you can write down in your course register, because this definition can come in examination. Uh, explain the explain the difference between truss and frame. So write down the first. In case of truss, load is applied only at the joints. So you can see from the diagram. So make this diagram. And for the frame, in case of frame, load can be applied on the joints and also on the members. Fine?
सर एक्सक्यूज मी
Yeah.
सर
Yes.
सर द रेलवे जो वो शेल्टर्स होते हैं यूज से
Yes.
कि उसमें ट्रस होते हैं वो जो नीचे बना रखी होती है उन्होंने
No, no. I am saying the railway platforms, the roof of the railway platforms.
यस सर
Yes, that is in the shape of truss.
सर उसमें फ्रेम नहीं कहना चाहिए क्योंकि उसमें भी तो जो ऊपर टिन शेड होता है वो पूरे मेंबर के ऊपर होता है उसके नॉट ऑन द जॉइंट
Okay, listen to me. They can be truss or can be frame both. Okay, I am just telling the example. They can be
Okay.
truss or on the frame. Okay, because both have the shape of triangle. Now it is clear.
ओके ओके सर
Okay, So can you have you written the definition of frame also, which I have dictated?
Sir, please repeat.
Okay, I am repeating for the frame. In case of frame, load is applied on the joints and also on the members. Fine. So this difference you should know when you are solving the numericals. Now comes to next part, analysis of truss. So I will dictate some definitions here because that is very important from a theory point of view. So before doing that, I am just going to explain one more thing, analysis of truss. For the analysis of truss, we have three methods. Method of joint, method of section, and the third is graphical method. Fine. What is the meaning of analysis? Meaning of analysis that we have to see how many forces are acting on the truss and due to which the truss is in equilibrium condition, or you can say truss is not deforming. Though we are considering the case of perfect truss, so we will assume that it will not deform under the application of force. So we only need to calculate the forces in the different members. For example, I am taking this truss here. Okay, this is one truss. Hinge support, roller support. Let us give two loads here. Now see, let me label it so that you can able to understand it more clearly. Now you can see here, this is a truss which is a assemblage of three triangles. Fine. Now, what is the meaning of analysis? Analysis, the meaning of analysis that we have to find the forces in various members. How many members are there? 1, 2, 3, 4, 5, 6, and 7. So we have in all 7 members are there. So in this we have 7 members. And how many joints we have? 1, 2, 3, 4, 5. Okay. So this is the joints here. Fine. So if you apply m is equal to 2j minus 3 equation, you will find that this equation will be satisfied. M is 7, j is 5, so 5 into 10 minus 3 is how much? 7. If you apply it here, so it will be same. LHS should be equal to RHS. So we will assume that this truss is a perfect truss because this condition is satisfying here. Now see, what the analysis means? We have to use 3 methods, and this method is not in your syllabus. But I just explained it there that there are 3 methods for analysis. This method is not in your syllabus, so you are to concentrate only for these methods: method of section and method of joint. So I will write here where we have to use method of section and where we have to use method of joint. Though I have explained it in this beginning of this second module, but I will tell once again here. When we have to use method of joint, when you are solving the numericals, nothing will be mentioned there that whether you have to use method of joint or method of section to solve the problem. So you have to identify by the statement of the problem which method you have to apply. So I am writing here, method of joint can be used when forces in all the members of truss is required to be find out. Okay. So we can use the method of joint only when the forces in all the members of the truss is required to be find out, and method of joint, method of section when we have to use. I am writing it also here. It is used when forces in few members is required to be find out. Okay, so when we are saying that forces in all the members are to be find out, you can see this example here. So in this example, 7 members are there. If I say to you that calculate the forces in all the members of trust, then directly this means that you have to use the method of joint. Okay, and if I say to you that calculate forces only in, let me, for example, calculate the forces only in the FAC, FAD, and FBC. Okay, if I say to you that calculate the forces only in the members FAC, FAD, and FBC, only 3 members, then you have to use method of section. So it is clear now when you have to use method of joint and when you have to use method of section. Is it clear?
Yes, sir.
So this is very important for you to learn, because one question from the trust always come in examination, 1 or 2 questions. If the MCQ mode is there, then there will be definitely one numerical problem. And if you have to give the examination in the campus, there also you have to solve the problem. So this is a bit lengthy problem. It will take about 10 to 15 minutes. Okay. So understand the numericals on trust very carefully. So before solving the problem, you should know which method you have to apply. So I have explained here which method is to be applied in a particular problem. Method of joint when all the forces are required to be found in the truss, and method of section when only few members is required to be find out. So I think till now it's clear what I have told you. Starting from truss, perfect truss, imperfect truss, conditions, then difference between truss and frame, and then analysis of truss, method of joint where you have to use, and method of section where we have to use. Then I will tell you what is method of joint and what are the different steps you have to use to calculate the forces in members. Before that, I will just dictate you some theory part that is very important. So write down the theory part. I will dictate here. Very simple theory. Uh, First, write the definition of truss. You have to maintain the course register. Okay, what I am telling you. So these course register will also comprises marks. So write down the definition of truss. It is a structure made up of several straight members. It is a structure made up of several straight members which are bolted or welded, together, to form a network of triangles, full stop. It is an assemblage of number of members. It is an assemblage of number of triangles that can resist the geometrical distortion, that can
Can
resist
you
the
please repeat? It is
from,
an
from where I have to repeat.
sir. Last line. It is an
Okay, it is an assemblage of number of members that can resist the. If any spelling you want to ask me, I can write on the board. Spell check if you want to tell. If you want to make, I can make it on the board. I am repeating it once again. It is an assemblage of number of members that can resist. Spelling of this is very simple. That can resist the geometrical distortion under the under any applied system of loading. Under any applied system of loading. For example, these are used in bridges These are used in bridges, comma transmission towers. These are used in bridges, comma transmission towers, comma roof, etc. So, have you noted the definition of trust? Should I repeat, or it is fine?
Fine.
So please repeat.
So I am repeating the definition of trust once again. Please make the notes properly. Theory part is very, very vital for you. Okay. It is a structure made up of several straight members which are bolted, comma, welded together to form a network of triangles. Full stop. It is an assemblage of number of members that can resist the geometrical distortion under any applied system of loading. Full stop. For example, these are used in bridges, comma transmission towers, comma roof, etc. Fine. The definition of truss is clear. Now comes to classification of truss. Classification of truss. I think you can make by yourself classification. Perfect truss and imperfect truss. You can make it by yourself.
Yes, sir.
Because I have explained you the diagram and I explained m is equal to 2j minus 3 question should be satisfied. And secondly, what is the second condition? Can anybody tell? First is
Not
m is equal
deform
to 2j
under
minus
the
3.
load applied.
Yes, yes. It should not deform under the application of load. Okay. So you make these definitions of perfect and imperfect truss from the book. Now comes to very important part, assumptions during analysis of truss. Assumptions. I'm writing here if anybody is not able to understand. Assumptions during analysis of truss. So whatever we are studying here, we are studying for the perfect truss. Okay. Assumptions during analysis of perfect truss, or you can say truss. So number one condition is assumptions. The end of the members are assumed to be hinged or pin connected. The end of the members, number first point is end of the members are assumed to be hinged or pin connected. Pin connected means all the roller point is there. Second point are assumed to be hinged. Hinged means you know very well, are assumed to be hinged or pin connected or roller. Second point, load and reactions. Load and reactions are assumed to act only at the joints. Load and reactions are assumed to act only at the joints. Number three, sorry, self weight of the member. Self weight of the member is assumed to be negligible. Self weight of the member is assumed to be negligible because it is very small, as compared to the load which they carries. It is very small as compared to the load which they carries. So we will assume that self weight is negligible for the members. Now write the last point, last assumption in analysis of truss. Truss is statically determinate. I am writing the spelling of this. The truss is statically determinate and is a perfect truss. Truss is statically determinate and is a perfect trust. So can anybody tell me the meaning of statically determinate? What is the meaning of this line, statically determinate? Can anybody tell? Any one of you?
It is it is pinned to a single location. It does not move.
No. Statically determinate means not like that. It's a very simple meaning of this. You are making it little complex. So anybody else can explain me what is the meaning of statically determinate?
सर बेंड वेंड नहीं करेगा वो.
Okay, then.
सर फोर्सेस इक्वेशन ऑफ स्टैटिक से निकल आएंगी जो एक्ट करेंगे.
Yes,
इक्विलिब्रियम
exactly.
कंडीशन में होगा.
Yes. Equilibrium condition is maintained. That means we can find the various forces in the members using the equation of statics. Okay, this is the meaning of statically determinate. Equation of statics. So what is that? Summation fx is equal to 0, summation fy is equal to 0, and summation m is equal to 0. We require 3 equations. Fine. So if a truss is solved, or you can say if the analysis of truss, or we can say if we can find the forces in the various members of the truss using the equation, these equations fx equal to 0, fy is equal to 0, and moment is equal to 0, then we can say that the truss is statically determinate. And perfect meaning I have already told you. What is the meaning of perfect truss? You know it very well. It should satisfy the condition m is equal to 2j minus 3, and it should not deform under the action of applied loads. So it is clear, till now it's clear, till now theory part is clear. This is the theory part of the truss. So when you are practicing, or when you are preparing for the major exam and also for the class test, then you should know what is truss, then you should know what is perfect truss, what are the equations for the perfect truss, what is imperfect truss, and what are the different assumptions during the perfect truss. And later you should know what is method of section and what is method of joint, and how you will solve the truss using the method of joint and method of section. So till now it's clear what we have done today.
Yes, sir.
Okay.
Yes, sir.
It's done. So I will start method of section, because in this I have to explain what is method of joint, and I have to write the steps. So this is very important here. I will tell you very important care point here. You should listen it very carefully, that whatever steps I am telling you right now in the method of joint, you have to use those steps only, because in books assumptions of directions are different. Okay, some books are taking tensile direction, some books are taking compressive direction, so you may get confused and you may get the different answers. So stick to the basic part which I will tell you in the class. What are the steps you have to follow, and follow those steps only. Fine. And with that step definitely you will get the answer. So don't change the assumptions. Whatever assumptions I will tell you, you have to use those assumptions, because in the truss only the thing that you have to, how you are taking the directions, how you are assuming the force direction, is vital. If you don't take it properly, then you will not get the answer. And you can see this. You can see this truss. This is a 7-member truss. So truss member can be 10 or can be more than 10. So if you get the any value different, you can say everyone is connected with each other. You can see AB member is connected with BC, AC. So if you get any value of the member different, then definitely other members will be different. The values of other members will be different. So whatever steps I will explain you, just follow numericals. Don't follow the steps of the books, otherwise you will get confused. So this is the only thing you have to remember in truss. So tomorrow I will start with method of joint. I will explain the steps, and then I will solve one numerical tomorrow, so that you can understand it properly. Fine. Anything you want to ask from today's lecture?
No, sir.
For today's lecture, you understand everything. That means. So let us take the attendance now. I am unsharing the screen. And let me take the attendance. Jashandeep Singh.
Present, sir.
Hmm. Then Rama. Rama. Then Divyam.
Present, sir.
Mohit.
Present, sir.
Shekhar.
Present, sir.
And Sahil.
Present, sir.
And Vanshika.
Present, sir.
Vidhi.
Present, sir.
Shivansh.
Present, sir.
Hiren.
Present, sir.
Sani.
Present, sir.
Okay. Then Samir Chaudhary.
Present, sir. Samir Chaudhary, present.
Okay. Sudiksha.
Present, sir.
Then Yash Kapoor.
Present, sir.
Then Vanshveer Singh.
Present, sir.
Then Sankirat.
Present, sir.
Neha Goyal.
Present, sir.
Parth Batra.
Present, sir.
Aditya.
Present, sir.
Aditya Raj. Okay.
Present, sir.
Okay. Satvik Chaudhary.
Present, sir.
Satvik. Okay. Then we have Aditya Kumar.
Present, sir.
Then Prajwal Goswami.
The Prajwal.
Shantanu Raj. Shantanu.
Present, sir. Present, sir.
Okay. Then Naman.
Present, sir. Naman.
Then Yuvraj.
Present, sir.
Poshak has left. Then Nikita.
Present, sir.
Pragati. What is the status of Pragati? Do anybody knows? Anybody knows from Y-Batch student? Who, anybody knows about the status of Pragati? She is not attending class. So let me know the status from the PL.
So maybe
Yeah.
she left the college.
Okay, you just
Not sure.
CR, you just that's why I'm saying CR, please confirm with the PL and then let me know whether Pragati has left or still there, because this information is very important for us.
Okay.
Fine. Then we have Arunit,
Present, sir.
then Hemang Bhatia,
Present, sir.
Aryan Anand.
Present, sir.
So nobody will leave the meeting. I want to discuss some important thing. Okay. Nobody, please. If somebody has left, please rejoin. Just inform them. I want to discuss one thing. And after that, Rakshit Malik,
Present, sir.
then Aryan,
Present, sir.
Nibir.
Present, sir.
After Nibir, we have Path Bansal.
Yes, sir. Parth Bansal present.
Okay. Then Bhavya Singh.
Present, sir.
Okay. So Gitan Sharma is not in your class.
No,
Anybody
sir.
know any information Gitan Sharma, because his name is reflecting in our Amazon. That's why I'm asking you. So confirm this also from your PL. Okay. Gitan Sharma is in some other section, or he has not joined, whatever it is. Joined the college, whatever. Please give me the status of Gitan Sharma and this Pragati Mehra. So for the Kushagra, again, you are 100% confirmed that he has left.
Yes, sir.
Yes,
He has
sir.
left.
Okay, so it's fine that Kushagra, then we have information. Just give me the information of Pragati and Gitan Sharma tomorrow. So I want to ask you one more thing, because we have taken one surprise test and one we have taken the this one minor test has been done. So what is the status of your surprise test? First of all, tell me, do your surprise test was well? All of you have performed well in that? Yes, can anybody tell me what was the status? Have you performed well in that test or not? Because accordingly, I will decide some other test. Otherwise, I will take that test into consideration.
सर वो मैं चेक हो गया तो मिला नहीं है सर.
रिजल्ट तो मिला ही नहीं
Sir,
उसका.
we didn't get the result for
सर
this.
उसका रिजल्ट नहीं
Yes,
मिला.
Listen to me, what I am asking you. I am not asking you for the result part. I am asking you that whether you have performed, you should know by yourself what you have done in the test. I am asking that thing. I will
टेस्ट तो हो गया था
give
सर, आसान टेस्ट है, लेकिन उसका रिजल्ट नहीं मिला था.
आसान टेस्ट था, बट आंसर का वो थोड़ा डाउट है ना कि टैली हुआ नहीं हुआ, लाइक करेक्ट है नहीं है.
यस सर.
लाइक क्वेश्चन सही है, एफबीडी सही है, लाइक फाइनल आंसर.
Okay, okay. That means I will assume that you have done that test well. I just checked that test and just release the marks. You want
यस सर.
this thing. That means I will consider that surprise test for the marks. Okay. So
सर
yes, tell.
मेरे को थोड़ा गलती हो गई थी उसमें फर्स्ट वाले में थोड़ी. यस सर, मेरी भी.
Okay, so don't worry.
Mine too.
Okay. Now you can all mute your mic. I can tell you, I will take two more tests. Okay, I will take two more tests, but those tests will be surprise test only. So please keep on studying. I will not take like that. I will just tell you that today, tomorrow I will be taking tests. So keep on preparing. So whatever the surprise test will come, it will be coming for the second module. For the complete beam, it will be
Excuse me,
there.
sir.
Yes, Naman.
सर आप अगर लोगे भी तो सर प्लीज मंडे के बाद लेना, क्योंकि सर मंडे को हमारा
I
माइनर
am
है
not.
एफबीएल उसका.
Don't worry. I am not taking it right now. Don't worry.
ओके सर.
I am not
Okay, sir.
taking it right now. I'm just informing you that I can take the surprise test on any date. So you have to keep on preparing it. That will not mean that I will take test tomorrow on Monday. So I will take test any day. Maybe after Diwali, maybe before Diwali, whatever it is, as per my convenience. So please be prepared for it. So I will take two more surprise tests. Fine. So accordingly, then I will put the marks. And lastly, course register you have to maintain properly. Please maintain the course register and solve all the questions. Fine.
Yes, sir.
That's all from my
ओके
side.
सर.
Yeah.
So
Okay, sir.
finally can you please tell that